All right, so let's continue further now. So now let's go over a scalar multiplication. So it is possible to multiply a vector by a real number c. In this context, we call the real number c a scalar to distinguish it from a vector. So there's a real number c is a scalar. There's a vector. This one just has magnitude. This one has a vector has direction and magnitude. So for instance, we want 2v to be the same vector as v plus v, which has the same direction v but is twice as long. So in general, we multiply a vector by a scalar as follows. So definition of scalar multiplication. If c is a scalar, well, again, this has to be unbold. Yeah, so if c is a scalar and v is a vector, then the scalar multiple CV is the vector whose length is this c, the absolute value of c, times the length, because this is the length of it, because sometimes you can have a negative, so you could flip it and so on. But this is the absolute length there. Yeah, so that's just the length, which is a positive number. So is the absolute value of c times the length of the vector v, and whose direction is the same as v if c is greater than 0, and is opposite to v if c is less than 0. But if c is equal to 0, or v, or the vector v is equal to 0, then c times the vector v is equal to 0. Yeah, equals to 0 as a vector and magnitude. So this definition is illustrated in the figure below. All right, so what I'll do is I'll draw v. Say we have v. From here to here is v. All right, so now if you have 2v, you're going to double that. This is going to be 2v. All you do is extend it double. So that's 2v. And now let's say you have 1/2 v. Well, 1/2 v is going to be half that. So this is going to be 1/2 v. All right, so that's 1/2 v. Just fix that up. And now if you're going to go negative, this is going to be, well, start exactly the same, but go down. This is going to be negative v. And now if we want to go negative but bigger than that, we can go up to here. This could be negative 1.5 v, negative 1.5 v, like that. Yeah, so this is scalar multiplication. So we see that real numbers work like scaling factors here. And notice that they're all just scaled up or down in opposite directions or same direction. That's why we call them scalars. So we're just scaling the vector. And now notice that two non-zero vectors are parallel if they are scalar multiples of another. Yes, for example, all of these are just parallel because they're all going in the same parallel direction, either forward or backward. It's still all just a parallel with each other. All right, so in particular, the vector minus v which equals to, let's put this, you could put this as a unbold, but it's the same thing. So a negative v equals to, actually we'll just do it for clarity. So negative v is equal to negative 1 times v has the same length as v, but points in the opposite direction. So notice here, these are parallel, so this v goes up, this one goes backwards there. It's the same length though. So we call it the negative of v. And by the difference u minus v of two vectors, we mean u minus v is just equal to u plus the negative of v. So this negative v then. So we can construct u minus v by first drawing the negative of v. Here, just put the negative of v, and that is a negative v, and then adding it to u by the parallelogram law as in the figure below. All right, so we can draw that here. So let's say we have u, and let's say we have u going like there. There's u. And there is v. So we have v goes like this. This is v. All right, so to construct u minus v, well, we're going to add, it's the same as u plus negative v. So we'll take the negative of this. So we'll go backwards. Like that. Let's start a bit nicer. All right, here, just fix that up. So this is negative v like that. And now we can construct it using parallelogram law. That is basically just construct a parallelogram. So we can construct like this. And like that, and then just combine this straight over there. So this is going to be our u minus v, like that. All right, here, so I just moved it up here and made it a bit neater. So alternatively, since v equals to u minus v, No, I mean, yeah, v plus u minus v is equal to u, because you can just see here. So v plus u minus v, the v's will cancel. We're just left with u. The vector u minus v right here, when added to v, gives gives u. In other words, if you take this vector v, add this one here over to this part, we're going to get over there. And that is going to get over to u there. So in other words, we can construct this using this triangle law there. I'll just erase all this. All right, so yeah, gives when added to v gives u. So we could construct u minus v as in the figure below by means of the triangle law. So what we'll do is we could draw u here, and then v is here. This is v, and then we'll just go downwards. This is just u minus v. Yeah, so basically instead of adding u on top, we can just subtract it like this. And that is using the triangle law there. Let's move this up. Yes, that's fascinating stuff. All right, so now let's continue further and look at example 2. So if a and b are vectors, are the vectors shown below, so here's a, here's b. Now we're asked to draw a minus 2b. So solution. We first draw the vector negative 2b pointing in the direction opposite to b. So we're going to go here and twice as long. And we place it with its tail at the tip of a. And then use a triangle law to draw a plus negative 2b as in the figure below. Alright, so what we'll do is, because again, we're asked to get a minus 2b. So what we'll do is a plus negative 2b instead, because we'll just be adding it up using triangle law. So we'll draw a. So there's a. I'll just draw it here. So there's our a. It looks something like that. I think it's a bit longer. Let's try a bit longer. There's a. Now we're going to look at this b, put it right here, but then do the negative of it and twice as long. So this can be, instead of here, it'll be like that. So this is our negative 2b. And now when you combine these together, you get the triangle law. So this will be a plus negative 2b, which equals to a minus 2b.